let's take a look at series as opposed to sequence. Remember, series is when we simply put the plus sign in between all the terms and add them all up. So the sum of the sequence. Oh, there you go. There's a definition, I guess. You get the first term, add it to the second term, add it to the third term, all the way up to the nth term. That's the sum to n. Or using sum notation, which of course is capital sigma, of the general term, and we're starting from the first term going up to the nth term. That's a nice shorthand way of writing out the sum. So if I do it like that, I don't have to write all the terms out. I can say, oh, okay, I'm just summing up. There's the general term. I'm going to start at the first term, finish at the fifth term. All right, if I did write them all out, okay, well the first one's going to be 2 plus 3, next one 4 plus 3, and so on, and we get a total 45. Not a very efficient way of finding the sum, but of course you can do it that way. Now if we know the sum to 10 terms is 29 and the sum of 11 terms is 37, then of course we could now find what the 11th term is, because it has to be the difference between the two, because we've added the 11th term on. In this case, that would be 8. So using that idea, if I have been given a formula to find the sum, then I can find a formula for the general term itself. Because I could use that same idea and say, well look, I know that general term will be the sum to n, but I would subtract the sum of n minus 1. That would leave me with the nth term, right? Let's sub in. If we expand that whole thing out, we get 10n minus 5. There's the general term for that expression. Well, let's look at the arithmetic series in particular then. So what do I know? If I wrote out all the terms, I got the first term, then I'll add the second term, and so on. I'd keep going until I got to the last term. So let's just call it L for the last term. But the term before the last term must have been L minus D, and the one before that must be L minus 2D. In fact, that's so good, I'm going to write it again, but backwards. Now why I do that is I've effectively created simultaneous equations now, but if we match it up, we get something neat. Adding the two sum to n's, obviously I get 2 sum to n, but look at this. We get a plus l, but then a plus l, the d minus d cancels, a plus l, the 2d and the minus 2d cancels, and that just keeps going. So we just get a whole heap of a plus l. And the question is, how many of them? Well, there must be n of them, because we did that for each term, and we know there's n terms. Divide both sides by 2 and we get a formula, which is great if we know what the last term is. If we don't know what it is, that's fine. For the last term, I'll just substitute in the general term, a plus n minus 1d, and we get another formula that we can use if we don't know what the last term is. We get n on 2a plus n minus 1d. So we know the first term's 3, we know the sixth term is 96. We want to find what the sum of those 6 terms would be. So we need to extract all the key information. We know a. The other thing we need to know, oh, hang on, they've told me the last term. I could just simply use the sum to n where it's a plus l formula for this. A basic substitution question. 297. Find the sum of the first 100 even numbers, and let's just pretend for right now that we don't actually know what that last even number would be. Just can't work out what that 100th even number is. In that case, I'd say, well, the first term's 2, the difference is 2, there's 100 numbers that I'm going to use. I'll plug it into the other formula then. Plug that in, and we get 10,100. The sum of the first 10 numbers is 100. The first 5 numbers is 25. Let's find all the key pieces of information. We're going to find the first term, what that common difference is, and then come up with a formula for the general term as well. They've told me the sum to 10 terms is 100. 10 on 2, 2a plus 9d, that'll be 100. Tidying that up. Sum of the 5 terms is 25. Sub that one in, and we get a plus 2d is 5. 2 equations, 2 unknowns. We should be able to solve it simultaneously. Let's play with that. The common difference turns out to be 2. First term is 1. Now let's find the general term, a plus n minus 1d. Substitute in what we've found, and there's our general term, 2n minus 1. A nice final conclusion, giving them every piece of information they were looking for. So tidy it up with, well, therefore a is 1, d is 2, and the general term is that. Okay, let's look at nature C1. So this one happened a few years ago now. The cards are stacked to build this house of cards, and they've given us a picture where 3 of the rows have been done. And so each house of cards requires 3 in the top row there. The next row would have 6, and each time there's 3 more cards in the row. We have to show that a house of cards with 12 rows would end up having to use 234 cards to build this house of cards. Alright, what do we know? We know that the first house of cards has got 3 cards. We know we're adding 3 cards every row, and n is 12. So we'll sub it in to our formula, and eventually, now, yes, important. It's a show that question, so don't be lazy. Don't just go, I'll go to my calculator. Oh yeah, look, that's the answer. They're asking you to show it. So that substitution step where you actually plug the numbers in, that becomes important. And there we go, 234 is my final answer, which is what we were expecting. There's another house of cards. It's got 828 cards in it. How many rows we used? Well, the sum of all the cards then is 828. That's what we know. We're subbing everything into that, and we've got to solve this. Looks like we're going to get a quadratic. We do. What multiplies together to give minus 552 adds together to give 1. It's got to be a positive and a negative. If they differ by 1, it's got to be pretty close to the square root, doesn't it? If it differs by 1. What's the square root of 552?
23.49.
It's so it'll be around there. 23. What do we get? Oh, there you go. 24 and 23 are indeed the 2 numbers. We have 2 possibilities for n. Now, they are possibilities, of course, for this quadratic. Always go back to the question, one of these doesn't make sense. You're not going to have negative 24 rows, so it must be 23 rows for our house of cards. Here's one where it's in sum notation. There's our general term. First term is negative 3 when we substitute 1 in. The last term would be 24 when I substitute 10 in, and obviously there's 10 terms, so I can extract all that information, 105. I don't need to write out all the terms to do this one. Alright. Oh, one thing to watch out for with sum notation though, make sure it is starting with n equals 1. Don't fall into the trap where they start it with like n equals 3 and then just out of habit you go, oh, the first term, sub in n equals 1. It also means it will affect the number of terms you have. Don't make the mistake. If this started with n equals 3, how many terms you got? Right? Don't go 10 minus 3 is 7 because it's inclusive. It's got both ends. So it'll be 10 minus 3 plus 1 would be the... Okay.